Well, hello there, folks. I hope you're doing well. In this video, we're going to be talking about Chapter 8.6, Trigonometry, Calculating Angles. You'll find this on page 230 of your workbook. So let's start off with the try these. Is the given ratio for the angle A the trig ratio for sine, cosine, or tangent? So it's a little bit of review. So I'll first start off with my angle, just to look out over here. Okay, so 5 divided by 13. 13 is my longest, so that's my hypotenuse. 5 is the side that is adjacent to angle A. That's not my hypotenuse. So I have adjacent over my hypotenuse. That is the cosine. So 5 over 13 is the cosine ratio of A. For number 2, 12 over 5. 12 is the opposite side, so I have opposite over adjacent, which is my tangent ratio. Finally, I have 12 over 13, which is my opposite side, divided by my hypotenuse, which is my sine ratio. Not surprisingly, it's the only one we haven't used yet. So that's it for the try these, the review of these guys. So we've been able to use angles to find a missing side, but how do we use sides to find a missing angle? As a review, the angle of elevation is the angle between the horizontal and the line of sight when looking up at an object. Because Gerolf, I don't know, is a lifeguard. At 2 o'clock, his shadow is 76 centimeters. What is the angle of elevation of the sun at that time to the nearest degree? So looking up at the ground, past his head, right from the shadow, what angle am I going to see? Luckily, his shadow makes a right triangle with him that is completely related to his height. So we are going to figure that out. First of all, which trig ratio relates to the unknown angle? Well, we have our unknown angle. We don't know our hypotenuse, but we know our opposite side and our adjacent side. And the opposite side divided by the adjacent side is the tangent. So we are looking for the tangent ratio, or we're using the tangent ratio to find the unknown angle. What is the equation? Well, the tangent of x is equal to 170 centimeters divided by 76 centimeters, or 1.7 meters divided by 0.76 meters. Either way, it's going to give us the same answer. Then to determine the value of the angle, you need to do the inverse operation on your calculator. The way that you calculate this is by pressing the second function key. So you hit second, which is on the top left of your keypad, right below kind of your screen. Second, and then tangent, and then you'll put in, we'll get to that part. So when you hit second tangent, you should get tan negative 1. So let's solve for x. Tangent of x is equal to 170 over 76. So x on its own is equal to tan inverse, so second tan, and then in the brackets I'll put 170 divided by 76, which is 65.9 degrees. But it wants it to the nearest degree. So when I get to the answer, the angle of elevation of the sun is about 66 degrees. And that's my answer. That's it. So to find an unknown angle, I figure out which of my ratios I'm going to be using, the sine, tangent, or cosine, and do the inverse, the second tan, sine or cosine, to figure it out. And so let's do an example to figure this one out. The example says, a cable is secured at the top of a cliff to create a zip line. What angle does the zip line make with the ground? What is the angle of depression from the top of the cliff? So we actually have two questions here. It's asking what is x, and then once we have that answer, what is y? And it gives us, let's look at it right now. So this is our angle. The side opposite the right angle, or the longest side, is 39 meters. So this is our hypotenuse. And this here is the one that is opposite our angle, so that's opposite. We need to do something that uses opposite and hypotenuse. Well, the one that uses the opposite and hypotenuse is the sine ratio. So the sine ratio is what we are going to be using in a moment here. So what angle does zip line make with the ground? Opposite, what I just said, opposite of the angle over the hypotenuse. And that is the sine of angle x. So the sine of angle x is equal to the opposite, which was, looking back, 15 meters, divided by the hypotenuse, which was 39 meters. So the angle x is equal to the inverse sine, or second sine, of 15 over 39, which when you type into your calculator, gives you the answer of 22.6 degrees. But it doesn't really say. We'll just round it to about 23 degrees. Now, how can the horizontal lines help you relate angles x and y? So let's look at those horizontal lines again. There's a horizontal line on the ground, obviously, but also one up here with the y. Well, the way that they relate is, if you remember going back to chapter 7, when you have well, first of all, horizontal lines are parallel. So if I have a line going through two parallel lines, I create matching angles. So in the case of these horizontal lines, I creates two alternate interior angles, is what they were called. Two alternate interior angles. And so when I have two alternate interior angles, they are identical. That was the rule that we discovered. So what that means is that the angle x is equal to the angle y. So angle y is also equal to 23 degrees. And that's it. So once again, I feel like they should probably give you more practice questions with this one, but they have not. So when you are looking for an unknown angle, figure out what information you have and take that information, so for the sides, and choose which you need to use, the sine ratio, the cosine ratio, or the tangent ratio. You then use the second button and choose that ratio to get that angle. And the way we represent that is, like, for example, sine and then -1. That means the inverse, so that's second sine. Hopefully this is clear. If you have any questions, please do let me know. Hope you have a fantastic day, and I will talk to you later.